Welcome. Welcome to Jupyter and Conda at NCAR. My name is Mia Trahan. I'm part of the CISL consulting group. Yeah, I'm sure that you've met with me if you've passed along any tickets. If not, then yeah, I'm more than happy to meet with you. Like, feel free to pass some tickets to our support group or stop by and say hi. Like, we love having visitors and having that conversation with people. Okay. So first thing first, number one most important thing, getting help, right? If you need help, right, there's two places to actually do it. There's here, and then there's also on our main documentation site. I'll go ahead and pull that up in a bit, but for now, this is just a little image for it. I'm sure you've all been to ARC. That little help button in those docs will go ahead and get you to a searchable documentation and get you support tickets for HPC consultants, right? So if you want to talk to me, you can click that little help button and you can send us a message, right? And we can go ahead and get you that help that you need. Okay? Cool. So just some topics to cover. I'm going to do like kind of a quick rundown of a bunch of stuff, right? Starting with like what HPC we're dealing with here, right? We'll talk about accessing Jupyter Hub and like little features about that. We'll go into what Jupyter Hub is and like specifics of like what you can do with it. We'll get a little bit into managing data, accessing software, and lastly, we'll get into Conda and start talking about what you can do with that and why you'd want to use it over something like Pip. Okay. Again, this is only an introduction. If you want to take a peek at our docs, right? We have two, one on ARC and one on the new site here, NCAR/HPC docs. All right, super cool website. Really recommend you check it out. I'm not going to click it here because it's probably going to freak everything out, so I'm not going to do that. But yeah, cool. So let's first kick off with a system overview and get into a little bit of Jupyter Hub. So this is derecho. I'm not super sure how many people have used it in here. Actually, can I get a show of hands of who's actually tried it out before? Ooh, we have a lot of people actually. So good to hear. I don't need to go over too detailed of this, but if anyone does have any questions, feel free to don't feel limited at that at all. But yeah, so as you may know, this is Cheyenne's replacement. It just came into service like, I don't know, about half a year ago. And now that Cheyenne's decommissioned, it's our only major HPC resource right now. No, not HPC, but yeah, regardless, yeah. So it was accepted and put in production at NWSC in August, right? It has 2,488 CPU nodes. And if you're actually really privy to that, that's actually less than what we had on Cheyenne. And that's because we're actually loading it up with massive dual socket 64 core AMD CPUs, right? So you get 128 cores per node now. Okay. So yeah, it's pretty massive, right? It's about 3.5x the Cheyenne performance, right? So yeah, if you haven't tried it out, this will be a good opportunity to start digging around with it. You have about 256 gigabytes of DDR4 memory per node. And yeah, we use Cas9 Slingshot as our interconnect, which is different than InfiniBand. It's actually a Ethernet solution, right? But pretty cool. There's some issues with it, but we're working on it all to get it all super smooth for everyone. Lastly, we have 82 GPU nodes. These are equipped with NVIDIA A100s. So these are very popular GPUs, a lot of AI workflows and things like that, right? So feel free to go ahead and start digging into these too. We want everyone to like capitalize and dig into these resources as much as possible. Okay. The next resource, Casper. So Casper is much smaller and much more heterogeneous of a resource for everyone. There's only 22 nodes for data analysis and visualization. Each node is equipped with 36 cores with 384 gigabytes of memory. And that's very, very different than what you would see in like something like derecho, right? Its focus is a little bit different. In fact, if you're like to have smaller jobs, like single core jobs or like, a bunch of single core jobs, this is the cluster that's perfect for that. Okay. We also have 18 nodes that feature large memory and dense GPU configurations to support exploration and machine learning. 4 of these nodes are V100s, 8 are another V100, but Yeah, and the last one is Ampere A100 GPUs. Okay, so we have a lot of variety in terms of what kind of GPUs you can grab. Next, we have 64 high throughput computing nodes, HTC. And these are for smaller computing tasks, right? Again, for those single core tasks I was telling you all about, right? So if you have a bunch of those that you want to like throw into one big system, pump them in there, that's a great place to do it. Okay. Cool. Any questions on this before I move on? No? Okay, boilerplate stuff done. Let's talk about logging in. This is not what we're going to be logging in with today. In fact, I'm going to ask everyone to not log into Jupyter yet. We're going to do it at the end because there's some issues with Jupyter that we're trying to work out. But yeah, this is the way you log in for like your base kind of like terminal way, right? Use SSH command, right? I'm sure a lot of people have used this before. And yeah, all you do is SSH-XY with your username, and you'll manage to access these two resources. Now, one thing to note, Derecho and Casper do have a little bit different of a URL now. Casper, you can actually still access with casper.ucar, but I wouldn't recommend it. Where we want to switch over to derecho.hpc and casper.hpc, primarily because it just makes domains a little bit easier for us to manage. So yeah, we want to have that as an available option. So please use the new URLs when possible. Okay. Cool. So logging into Jupyter Hub, and I don't want to do this real time yet, but we'll see. I'll try. But yeah, Jupyter Hub logging in, right? You can access it through jupyter.hpc.ucar.edu. And this will take you to our publicly facing Jupyter Hub instance that anyone with an HPC account can log into. Okay. So your login is pretty standard, right? You'll get your standard UCAR, NCAR login, sign in stuff, right? And then you'll get your Duo push, just like normal. And once that actually happens, you'll go ahead and get a list of servers listed. Okay? If you don't have any servers, if you list empty, right? You can go ahead and click that little start button to go ahead and get whatever kind of server you're gonna need for whatever workflows you need. This includes Derecho and Casper, right? So you can request either nodes, and they both have a login and batch variety. Okay. Next, I do want to point out, sorry, I skipped over a slide. Okay, so this is like the fill out page you'll actually get when you select Casper batch. As you can tell from people that have done HPC, all it is essentially specifying specific parameters that you would want, right? So you can request multiple nodes, you can request multiple cores, MPI processes per node, right? There's a ton of different little kind of minor grabs you can grab, or minor little details you can assign. And yeah, you can of course request a queue, a reservation, and like your basic project account. Okay, so all that stuff can be assigned in batch. Casper login, however, is a little bit more automated. It's going to throw you into a shared node with a single core. And from there, you'll go ahead and be able to do some minor kind of like workflow things, right? Whether it's building code or just testing some small code or managing even files and stuff like that. You can do that on Casper login. I don't recommend doing like anything big on it though, because obviously it's a shared node and we want people to be really kind of, I don't know, generous about like how you're sharing your node. Like the more stuff you use, the more challenging it gets for other people. So yeah. Now, once you actually click in here, right, then you'll get a bunch of different applications, right, listed on here. And I'm actually going to do a Jupyter tour now. Yeah, so please bear with me. I'm hoping this works out perfectly, but we'll go ahead and see. So I have a server up right now. I'll go ahead and click it. And it's going to go ahead and bring me to Jupyter Hub here. I hope. There we go. And you can see this is the interactive Jupyter Hub interface here. And do I need to make this larger for anyone? No? Okay, perfect. As you can see, we have a ton of different offerings of like different kernels, right? Or different like little varieties of software you can load, right? So like you can get stuff like bash, like just standard within your notebook, right? And if you click this, right, it'll actually bring up a bash terminal, right? Or bash script that would run using your standard kind of bash scripting kind of practices here. You can get an actual terminal as well. I'll go ahead and pull that up for us too. Just got that one. At the very bottom here, if you click terminal, you'll actually get an interactive terminal on a web UI. So if you're using a system that isn't equipped with a good terminal, like say you're running an older version of Windows, right, that doesn't have a lot of the features equipped, you can actually do and handle most of your terminal tasks on Jupyter Hub. Okay, and you get your standard things like that. Note that you're not actually on a login node. I know it says Casper login, but it's not technically a login node, it's a shared node. And that's primarily because we don't want people to basically overload the login nodes already more than what they usually are, because they're usually pretty slammed. But yeah, I can do my standard things like ls, right? I can cd to whatever directory I want to go. We'll go to my Scratch directory. Oh, I can't spell, sorry. It's always fun trying to spell while you're doing a presentation. Like things like that, right? So you get your basic kind of features. You also get like modules and stuff here too. So if you have used the module system on NCAR, you can go ahead and like see that all your modules can be loaded in this kind of terminal as well. So it can be loaded just like a standard kind of terminal. Note that this does not load it inside the Jupyter Hub instance itself, just in the terminal. Okay, cool. So yes, question. Okay, let me see if I can make it a little bit larger for us. Yeah, okay. But yeah, this is the basic setup though, and I'm not going to go too far into this. Yeah, file browser too, and like the basic stuff like summary of tabs and whatnot. I will show one really cool feature that we do have implemented, and something I wish we had at like different institutions too, but it's the module system actually in here, and this will load it into your Jupyter environment, right? So you can actually load your modules like right here on the fly, right, and build your software stack and like manage your workflows here using all these different little features. Okay, so you're not just limited to Jupyter kernels. Okay, cool. I go back to the slides. Any questions before I jump off? No? Perfect. Let's make this large again. And these slides basically go over the same kind of thing here, right? Like you can see there's the terminal stuff that I brought up earlier. A thing I didn't show is that you can show, like, this is like something that should be so trivial on HPC, but like it's always a nightmare to do, right? And that's just viewing images, right? So if you have like visualization work and it produces like a JPEG or something, right? Like you have this like wonderful option here. You don't need to do any SSH tunneling or anything like that, right? Just load up Jupyter Hub and you can just click the image and load it up. And yeah, that's basically the summary of what Jupyter kind of looks like in that environment. Oh, one thing I actually, I guess I'll show that a little bit later. But yeah, let's go ahead and hop into a little bit more details in terms of what the system looks like on kind of like a fundamental. So these maps are always super fun and super useful to like get a kind of a conceptual idea of what you're dealing with HPC. And that's essentially like where you are and where the HPC is. So as you can see, right, there's a workstation completely separate from, anything regarding the HPC. It's like your computer, you have all your files, your images, your whatever on there, right? And you go ahead and connect to one of the login nodes, right? These login nodes have the ability to go ahead and actually communicate with compute and the data visualization nodes, right? So it's like that kind of separate instance there. All right, so you're never really interacting directly with batch and compute unless you have like a specific interaction or interactive job going. Instead, you're primarily using the login nodes to go ahead and send out those tasks in a batch way, right? And go ahead and compete against those. And of course, we also have our two Casper login nodes, right? Oh, I forgot to change this to Casper.hpc, sorry. But Yeah, this does the exact same thing, right? The one difference here is that on Derecho, you can actually go ahead and submit jobs to Casper. I think you can actually do the same on Casper now, but I'm not too sure about that. Yeah, okay, you can do that too. So it's like crossover in both ways. You can use either login node to connect to either job scheduler. Okay, cool. And Cheyenne and Derecho and Casper use separate allocations. Yeah, unfortunately, like they're a little bit separate at the moment. But yeah, you're gonna need to make sure that you specify that you want to use Casper inside your allocation when you do request that. Okay. Cool. Now, being a good neighbor, yeah, again, your activities coexist with other users, right? So you want to be like as generous and like as kind to your users as possible, right? So you want to go ahead and make sure that you limit your resources on CPU and memory on login nodes. And we have it a lot more strict nowadays. If you haven't like been on that, like we have like an automated kind of robot going around killing people's processes. If you like, if you're not really respecting their roles, then it's going to run around and like, and it frustrates a lot of people, but like just know that comes from a good place, right? We really just want to make sure that everyone gets a fair kind of like piece of login nodes. Okay. But yeah, limit your usage to login nodes primarily for reading or editing text code, right? So if you're, writing up some script or something, right, that's perfectly okay. Don't worry about that at all. Compiling small programs, like you don't want to, like, I forget like the specific instance of this, right? But there's a lot of applications that are a lot larger than you're expecting, right? So you want to go ahead and make sure that you limit your application compilation to like small programs. If you need like a bigger kind of solution, you're building this massive code base, right? Then please make sure that you actually get an interactive job, right? It just makes things a lot easier for like the rest of us. Okay. Performing data transfers. This one can be a little bit more complicated, but generally speaking, if your data transfer is like, small to medium, right? Like up to like several gigabytes, right? Not several gigabytes, probably like tens, 20s of gigabytes, right? It's totally fine to do that. If you are transferring like 2 terabytes of data, right? Then you might want to like consider doing a different kind of approach there. You can either get an interactive node to like, if you're transferring files over to a specific directory or whatnot, right? Or you can like set up Globus to go ahead and transfer over to our data transfer nodes. Okay. And yeah, that's basically the entire thing. Oh yeah, interacting with the job scheduler. Of course, if you're using PPS commands, right, that's perfectly acceptable as well. But yeah, please don't run your applications on login nodes. Please don't do it. It's like, it just makes a mess for everyone. So yeah, thanks again. And programs are terminated again if they do start exceeding the resource limits that we have. Okay, cool. We have some changes here. So on Glade storage, right? I'm sure people have like started digging around with this, right? But on our new Scratch system, we actually give a lot more quota on default, and it lasts a lot longer. So I think on Cheyenne, you get 10 terabytes of data by default, right? So you could store that much just right off the bat. On Derecho, you can do 30, right? So right off the bat, no request needed, right? You just get 30 by default, right? And I think it used to actually last for 120 days prior, and now it lasts for 180 days, right? So it's almost half a year for you to get your data off Scratch once you're done competing against it. Okay. So lots of variety there. The rest is pretty much the same though. If you notice, so one of the major things that got depreciated was Glade/P, right? And Glade/collections and stuff like that, right? Most of that is all hosted in Glade/campaign now, right? And Glade/campaign is actually mounted onto Derecho and Casper now. Okay. So yeah, you'll go ahead and you'll be able to access your campaign storage there. Just note that if you do want campaign storage, you need to request for it in your allocation as well. Okay. And again, it's variable in terms of what the quota is, right? It's based on what your needs are. You just need to specify it in your allocation. Okay. Awesome. Do I have any questions in chat, by the way, or? Sorry, I'm like, it takes to get this. No? Okay, thank you so much. All right. Oh, and one last thing. You get this nice little command here, Glade quota. If you type this in your terminal, it will give you a very good summary. I'll go ahead and pull it up for you guys just to take a peek at it right now. Glade quota. And you can see it goes ahead and pulls up like a complete summary of what your storage space is currently being actively used, right? The different things that you have access to on the system. You can see that we still have P and U currently on there, or P on there right now, but that's going to be depreciated or deprecated, so avoid using that. But yeah, you'll get all these specific like little directories, right, listed out in this nice little command. Okay. Cool. Any questions before I move on? Perfect. So we also have collections. I don't know how many people have used collections here before, but this is basically our larger conglomerate, like we store, so essentially, right, we don't want everyone to like pull the same data sets onto like the same Scratch space or onto Scratch space and basically duplicate data there, right? So we made an effort to like make some very popular data sets available to everyone globally, right? These include RDA and CMIP 6. I think it's also CMIP 5, but yeah, so you can access both these data sets through a campaign now. Yeah, so I will, I guess, oh, I forgot to mark this. I'm so sorry. I'll go ahead and showcase for, oh, wait, no. Yeah, so essentially what these two are located, right, is in a directory called glade/campaign/collections/RDA or Simio CMIP, right? So that's what you're currently looking at there. Yeah. But yeah, any questions on these shared data sets? No? Cool. And lastly, I'll note here on campaign storage, right, just a little bit more detail here. Yeah, campaign storage is really designed for storing data on a project allocation on like timescales, right, of like 3 to 5 years. So it's a little bit bigger than like your standard kind of Scratch space and stuff like that, right? And it's really like focused towards publication and like, longevity of the data, right? Yeah, that you can expect the data to be migrated. You need to like make sure the data is migrated like after 5 years, but yeah, you can go ahead and like specify all that stuff in your allocation too. You can access it in multiple different ways. Globus, Derecho, Casper, and any kind of like data access node too. Right, you can access all of that there. And yeah, this is a cool little space that I do recommend you capitalize on if you do need it. And lastly, we'll talk about moving data to and from Glade. So really cool small thing you can do on Jupyter is that you can actually drag and drop files to Jupyter right on the file system. So if you don't want to like set up like, I don't know, SCP or something, right? You can do that with really small files, just drag and drop the file onto Jupyter and it'll go ahead and throw that in whatever directory you need it to. Okay. That being said, the two that we primarily recommend besides that is SCP and SFTP and Globus, right? So these, I guess, two commands in one major service. SCP and SFTP are really only designed for small data, right? You don't want to use like anything too massive there because if you do that transfer, right, then you have the possibility of the computer going to sleep or something, right, and you lose the data transfer. Like it's kind of sad, it's miserable, and no one likes it. So instead, if you're using anything larger than like, say, a gigabyte or something, I would use Globus. Globus is really awesome for transferring like large amounts of data, right? You can go ahead and pump away like, several terabytes of data, right? And what happens is if you have your computer shut down for whatever reason, Globus will go ahead and like put a little bookmark where that transfer is going, right? Or how far that transfer went along. And then it'll go ahead and complete the data set after you go ahead and restart that computer. Okay, so it can continue and drag that along, and it has a nice managed web UI. You do need to sign up for an account for it though. So, oh, and also install one specific small application called Globus Connect Personal onto your local machine. Okay, cool. Next, I'll talk about the software we currently have. Environment modules. I brought this up a little bit on the little Jupyter tour that we did earlier. But yeah, environment modules are very, very convenient because you can go ahead and load very specific types of software into your environment without needing to dig too far into like, changing paths or something like that. Okay. They also prevent loading incompatible software into your environment, and they'll actually force specific software off, right? If you want a software that is incompatible with whatever other version you might have. Okay. So yeah, here's our module commands here, right? These are for terminal. Again, if you're using Jupyter, right, you do not need to use these commands. You can just go ahead and click the little module load button, and it'll go ahead and load all that dynamically for you. But yeah, two big ones I do want to point out here is going to be module save and module restore. I see a lot of people doing this, and that's putting like a module load list inside their bash RC or in their C shell RC or whatnot, right? It is like, it can cause a lot of issues basically, especially if like we upgrade the system or change anything with the kind of environment, right? Then you can end up having a lot of issues like that. So I really, really recommend using this module save and module restore function to create a set of software you can load in one command, right? Like if your environment's not going to change over the span of like a couple of years, right? That's a perfect way to do it. Just module save your list of modules that you have currently loaded, give it a name, something cool, right? Like cats in a bag or something, right? And then module restore, cats in a bag, and you're good to go. All right, awesome. And here is some software that's older that I did not change here, but yeah, we have a bunch of different software listed in here, right? And I'll go ahead and do a little preview of that. I guess, right? I'll do after this modules Jupyter slide. Oh, actually, we already talked about this. I'll go ahead and skip it. But yeah, I'll go ahead and just give you a list here. Oops. So module load avail will go ahead and give you this big list of software we currently have available on the system. As you can see, yeah, we have quite a bit at the moment. One big change that's actually happened between the Cheyenne kind of era and the Caspen, like in the new derecho era, is that we actually have like a kind of desire to keep the software stacks mostly aligned. There might be some minor differences between them, but they're mostly aligned, as you can see. So yeah, as you can see, we have primarily like, for instance, MPT is no longer in there, right? Because that was a Cheyenne specific MPI resource that's no longer in there. So we had to switch over to a newer MPI, right? Which is Cray MPI. Okay. Cool. All right. Yeah, I will go ahead and scooch back to the slides here.
Mia, we have a couple questions in chat. Can you take a look at those?
Oh yeah, sure. Okay, I think the first one is just the two? Okay. I suppose the readily available data sets are read only. I believe so, yeah. Like obviously you don't want to like edit like, the larger kind of data set for the entire population of people. If you want to make any edits, just copy that or copy specific files of the data set to your Scratch directory, make the edits there, right? And can you show an example of how to use module save? Yes, let's go ahead and do a little example here. I'll go ahead and close chat here. And say I'm a big GCC proponent, right? GCC is my go-to, right? I love GCC, it's my favorite compiler. Well, let's go ahead and make a quick little module save command here, or module save chain here. So I'll go ahead and do module load GCC, and a quick shortcut if you're into modules, right, and making like really short command, right? You can do ML, and that stands for module load, or actually it's just module, but that will get you the same kind of thing, right? You can run ML GCC, and I'll go ahead and do module load GCC. Okay, you can see it switches out quite a little bit regarding what the software stack ends up being, right? You can see that we stick with OpenMPI on Casper, right? And everything else pretty much retains the same kind of flow, except for Intel, which is swapped out. Okay. Let's also say I'm also kind of interested in doing, let's just say, I don't know, GDAL. something module load, Gito. And yeah, we now have a little bit different than the base software stack. I can then go ahead and type module. Oh yeah, perfect. Thanks. List. You can see that the list is a little bit different than what you get by default, right? So let's go ahead and create a new little save here. So I'll do module save, right? And let's give this a fun name. I don't know, something cool. This will go ahead and create a little saved environment, right, to a collection called something cool, right, and list it specifically for Casper too. So you're not gonna have to worry about like managing between the two, right? This one's for Casper and it'll tell you it's for Casper. Okay, so I go module versus, so let's go ahead and switch it out again, right? So I'm gonna do a module purge, right? And oops, I removed a bunch of modules, right? Well, how am I gonna get this stuff back? Well, quick way to do it. Oops. And it's something cool. And I'll go ahead and restore all the different modules there for the Casper system. Okay. Cool. Last little note here. I'm gonna navigate back home. So there is a specific thing for your, like if say that if you need to make some modifications to your module lists, your saved modules, you can actually check it out through the lmod folder. I think it's .lmod-d. And you can see that we have, I already made a few of these, right, to showcase the ability prior, right? But you can see something cool.casper is located in here, right? And I can go ahead and cat this, right? And this file is actually pretty editable too, right? Actually, no, it's not. I was wrong. I thought it was, but I totally forgot. But yeah, this is like the specifics of what happens here, right? In terms of how things are loaded in, like it's just all the configuration. So if you ever want to get rid of this, you can just delete that file and I'll go ahead and remove it. Okay. Cool, great questions, yes.
I noticed that you typed ML. And is that just for you or is that for anyone?
That's for anyone.
Okay, so I typed ML without anything and it kind of gave me module list. So is that if I put ML and then a name of a module, it'll load it, but if I just type ML, it will list?
Yeah, so I think what actually happens if you type ML, it gives you so let's just try it, right? So if I type ML right here, right, it's gonna give me our currently loaded modules instead of the actual module list command, right? So what you want to do, right, is you want to just pair up ML with whatever normal kind of suffix you'd have, right? So you do ML restore, ML save, right? It's just shorthand to remove that module keyword, right, primarily. And it'll go ahead and also remove like module, the load part too, if you ever need to remove that load part. Okay, great question. Any more? No? Something in chat? That's cool. Yeah, it is pretty cool. I really like it. Again, use as much as you can. Yeah, I'll go ahead and pop back to the slides here and let's go ahead and finish up the rest of this. I think I only have 25 minutes to get through the rest. Okay, so let's talk about something I'm very, I guess I'd say passionate about. I don't know. I love Conda. Conda is like one of my favorite things, and I dug into it a bunch at my previous job. So I really, really recommend, like, highly recommend using Conda, like over pretty much anything in terms of like what you'd use with Python. But yeah, Conda. So Python is awesome, right? It's really easy to get started with Python, right? I'm sure the last presentation showed how easy the syntax is, like even like the libraries and stuff, right? You can use pip to install things really quickly, right? Especially if you're like on your personal machine or something, right? It's really cool, right? It has a ton of powerful community-driven packages, right? Including stuff like Dask, NumPy, TensorFlow, right? All these really juicy packages you can dig into. And yeah, oh, keyword here, package is basically the software that we're talking about, right? That we can load in. But yeah, Python's really great because you can do rapid development with whatever kind of goal that you want to possibly do. Like say, like, you know, you can even do stuff like kind of wild, right? Like I think I've done a little bit of like numerical analysis to quickly like test out like a theory or a way to do this prior, but like generally speaking right now, like the big focuses on this is data analysis and machine learning. Those are the two big ones that Python's really, really popular with. But yeah, Python is often pre-installed in a lot of Linux systems though. And it's not very capable of doing a lot of science just straight out of the box, right? Like if you actually run Python without loading anything on Casper or Cheyenne, you're not gonna really get a pleasant experience, right? So yeah, we'll talk about that in just a few seconds. We need some way of augmenting Python with new packages, right? Especially on shared systems, right? Like the one we have on an HPC. Pip, I love pip, but it also stinks. If you've ever installed a bunch of different software using pip, right, then you might know you would get this weird, like sometimes you just get a weird like conflict in package, right? It's like, well, this software doesn't match, or this software doesn't work with what you want to try to install. I'm sorry, I can't do it, right? And the error messages are super long, super convoluted, and not very fun to debug. Okay, I know that's super useful though, so I won't say knock it out altogether, right? But what I am saying is at the very least, use it as kind of a last resort, right? It's something that you want to use, right, if you're on your local machine, but if not, then definitely stay away from it until like you absolutely need to install it. Okay. The problem with this, right, is that essentially it tries to install a lot of things into like 3 specific locations, right, that are not very user friendly. The system library, which is a no-go on HPC. The user library, which is a little bit more convenient, but you can't really have multiple different versions of it. And a specific path or prefix where you need to remember where you actually installed all that stuff. Okay, which again, like there are 3 kind of like okay locations, but we can do better. Yeah, again, this is like the last little bits of limitations here, right? Pip packages are not portable, right? They're not typically portable, so don't expect to like move your pip packages around. And yeah, it also requires like kind of careful setup to actually do a lot of the building too, because sometimes pip is gonna not do what you want to have, not do exclusively what you want. But yeah, so the Python installation and its setting and package library collectively make a big Python environment, right? So all the different like software that you have and all the different like little resources and snippets that you have built into Python are your Python environment, right? And you even have like stuff like a Python path and stuff like that. So yeah, when you install packages, right, it just modifies the kind of the global pip pack or global Python environment, right? And it's a kind of a single kind of like constrained environment. So yeah, generally speaking, if you want a multiple though, then you want to stick with Conda. Conda is really, really cool. The reason why Conda is really, really cool is because of their extremely robust environment system. I had a colleague in the past call Conda not a Python like kind of interface, right, or Python manager, right? Instead, he called it an environment manager because he's used it to install different pieces of software aside from Conda, right? So it's really, really kind of robust in its utility, and since it's environment managing, it gets really detailed in terms of what it can do. So you can install all requested software into a self-contained environment, right? Completely separated. In fact, it has its own Python built into whatever environment you want to have, right? So you can have different versions of Python. You can do whatever you want with it. It's all contained in one specific Conda environment. It provides a powerful interface to install packages and switch between created environments, right? And I'm talking like you can have a data analysis set, a machine learning set, and whatever else you want to have right on the side. Just instantly, you do a Conda and you load up whatever you want to do, right? And you can load up whatever Conda environment you want to have. Lastly, it maximizes the environment portability by installing pre-built non-Python dependencies. So it actually manages dependencies for you, unlike pip. Pip does it sometimes, but it's never as detailed as what you'd want with Conda. Conda is extremely kind of tight-knit regarding that. But yeah, that's like the benefits of Python Conda. We'll get into a little bit of details, but does anyone have any questions in the meantime? I don't see it here. Oh, if you do have a question in chat, feel free to type it out. I'll go ahead and do a little poke and prod here, but yeah, thanks everyone for participating though. So how do you access Conda on Sysl machines? Two ways. So you can either do the mini Conda approach or just loading the Conda module. I recommend the latter, module load Conda, because it saves you the setup step. And I've actually had to go in and like sort out people's mini Conda installations, right, that were built like a while ago, right, to try to fix like whatever issue they currently have trying to load the new Conda, right? So I would stick with the Conda system level, right, unless you need a very specific version of Conda or want to customize it in some sort of unique way. Okay. The benefits of each, mini Conda is extremely small, extremely easy to install too. It's just a script, and it will go ahead and create all the basic kind of like components for you, right? Like a base Python environment, right? And it looks very traditional Python, except it gives you a little base prefix on your terminal. Okay. It'll also modify your startup files if you want it to. Again, this is like kind of easy to note, but it just like essentially it like goes into your bash RC and adds a few lines in there. Okay. Now, again, like if you don't want to modify a bunch of stuff, you just want your environment nice and clean, I again say stick with module load Conda. It's a lot easier, right? What's nice about it is that we actually maintain our own kind of library for you, right? So if you want to use all the NCAR provided stuff, right, that's more than like acceptable. You can just load in that Conda environment, and then you can load MPL, right, which is our little library of different modules available for y'all. And yeah, again, it doesn't interfere with your personal mini Conda too, right? Well, it kind of does. Sometimes not really. It's primarily primarily the other way around. Mini Conda interferes with that Conda. So if you're using mini Conda, I'd probably just stick to that, right? But if you want to like, if you want to load up and try the new system Conda, then you can go ahead and do that there. Okay. So just some commands here. So the first one, right, you want to load the Conda, right? Module load Conda, right? You can do that either on Jupyter Hub. I'll go ahead and just pull this up on a tab. So you can do this normally like ML Conda, right, or module load Conda. And that will go ahead and just get Conda available in your environment, right? And then you'll go ahead and have all the different Conda commands that you could possibly have, right? So I can do Conda env list. This will go ahead and showcase all the environments I currently have in my system. You can see it takes a little bit because I have a bunch of environments. You can see like there's a bunch. But yeah, you can see I tested and debugged a ton of different people's Conda environments too, right? And they're portable and like really, really convenient to play around with. But yeah, you can then go ahead and like say, I want to create a brand new one, right? Then I can use Conda create, or more efficiently Mamba create. Mamba is actually a more optimized version of Conda, right? That someone like went around and built in C, right? They're like, let's make this super fast. So yeah, essentially, there's breakout rooms apparently clicked on here, but I can go ahead and do this. Mamba create, and let's give it a name. I'll name this cats and bags. And we'll just install, let's just say I want some default Python 3. Okay, so I'll go ahead and add Python 3 or Python 3 like that. :3, that's basically just specifying the version. If you don't even care about that, you can just go ahead and delete the colon, right? And then that'll go ahead and prep an environment with you just with Python, so you can build on it, right? Just by loading into it. Okay. As you can see, it goes ahead and downloads all this stuff. And what's really cool is that's actually installing its own Python too. So it's fresh Python, brand new, right? Don't worry too much about the very details of it. It is brand new and fresh for you to install with. And once this is good to go, I can go ahead and load this in a few seconds. If not, I'll switch back to the slides and just show you the commands. I'm gonna switch back to this. Oh, there we go. So it's first gonna give me this option to confirm all these changes, right? And actually do all the downloading and building of the environment here, right? So it just shows me all the stuff that's gonna go in here, right? So you can see it actually builds pip in here too, as well as Python, right? So you can use pip with Conda too. It's not recommended to do unless it's the very last step of your build chain, right? But yeah, you could do that. So I'm gonna go ahead and say yes, and we're gonna go ahead and build this environment. And I'm gonna like let this cook for a second. Let's go ahead and hop back to the slides. But yeah, these are the commands. Essentially, you can expand this out to like get very different versions and whatnot here, right? So you get 3.11, you can get Wharf Python, GeoCat, Dask, right? You can get a bunch of stuff just like built into whatever environment that you want to have, right? In your Conda kind of build chain. And if you want to add more, then you can do Conda install whatever package you want after you've loaded that environment, and then I'll go ahead and let you build even further upon that one environment that you built. Okay, cool. Once it's created, I'm gonna go ahead and run this command, conda activate, and then whatever my environment's name is, and then we can go ahead and like try out Python, right, to show you the differences between those two. Let's take a peek. Yes, so in a conda environment is installing a third-party app compatible with the module loaded tools. No. I've had some experiences where they do work, but it's very, very it's not normally compatible, right? So don't expect it to function in that kind of sense, right? They're pretty separate in that kind of instance, right? So you want to install all your different software and just have that tool chain ready to go, right? And I'll go ahead and build whatever you need.
There are two, where kind of Conda is a little suboptimal, and that's only, for Python, it's the answer, right? Typically. When it installs a compiled application, something that's built from like C or Fortran, sometimes it uses like a lowest common denominator. It may not use all the features on your particular CPU. So if you have something that's available for both Conda and the modules, we would recommend the modules in that instance. The other case is MPI. So it'll often install an MPI that works generically, but not necessarily optimally with like a given, like specifically on derecho, that has a very proprietary network that comes from Cray, and Conda doesn't know anything about it really. So you won't necessarily get all the performance that's available. Aside from that, it's awesome.
Yeah, like what Ben said, I'm gonna repeat this just so like everyone in chat can hear it. Essentially, like you want to go ahead and avoid and you want to load modules that are built in, right? That are very optimized kind of software, right? Say like, a math library or something, right? Those are very, very specifically built with compiler optimizations to make it as very fast as possible, right? You also want to do it with MPIs. You'd rather stick away from Conda if you're doing your own kind of MPI installations, but yeah, that being said, like you can do it. It's just not recommended. You'll get slower performance, and your jobs are going to eat more of those precious core hours that you don't really want to expend. Okay. Okay. Another question here. Essentially, if I need to work on a project where I need a tool that is unavailable, you were advising that I create a separate Conda environment, install everything without needing to use module load. Again, I probably wouldn't recommend that. I'd probably just say like, if you can build the tool chain yourself, right? And like Conda is not like, an option, right? Then like, then please build that tool chain. That being said, right, if you're using Python or anything like that, right, that is probably the most optimal solution, is just going with the Conda solution. Okay. Thanks for the question. So that's a great question. All right, let's go ahead and take a peek at this environment. Hopefully it's finished by now. Yeah, so you can see that even gives you commands to go ahead and like do these activation commands, right? You can use Conda or Mamba to activate the command. I'm gonna use Conda. So Conda activate. Cats in bags, right? And this is gonna go ahead and give me a little prefix here that says cats in bags. If I go ahead and type Python here, This is gonna give me a specific version. This one's 3.12.1. Now I'm gonna type exit real quick. And we're gonna go ahead and unload that module really fast, or unload that environment by doing Conda deactivate. And from there, we can go ahead and run Python here, right? And you can see that we get a different version of Python. Okay. So yeah, it's really robust. Like things are very, very separated and very, very isolated, right? And you'll even get like, you know, pretty much as much isolation as you want using these environments. Okay. Cool. I will go ahead and switch back to the slides here. I have 9 minutes to get to the rest. I apologize. I'm going to try to blaze through it. Oh, I only like 10 slides, so we'll just keep going. Conda environments should not work, should work across most systems. That being said, if you're switching architectures, then I would probably rebuild the thing. Yeah, so Conda environments are really, really portable, right? Like most of the time, right, you can move them from system to system and pass them along friends, right? Especially if you're using the same HPC, right? You can pass them to that friend, right? And they can have like a build chain that they can go ahead and fill out, right? And there's a few commands I'll show in a little bit to go ahead and copy over like someone's Conda environment that's a little bit later. But yeah, that being said, if you're passing it to another friend at a different institution that's using Intel CPUs instead of, or ARM CPUs or something strange like that, right? Not Intel CPUs, ARM CPUs, or like using the M1, M2 Mac or whatnot, then you can end up with some kind of issues there. So yeah, you want to go ahead and like, you know, stick with using basic kind of CPU architecture, and it should be good to go to like port over to different people's systems. Now, that's great, but how does this work with Jupyter Hub? So if you see it, right, if I go ahead and go back to Jupyter Hub, you wouldn't see cats in bags on that Jupyter Hub screen that has all those like nice pretty buttons on there, right? It's kind of inconvenient to do that, right? Well, not really. In fact, all you need is a one command to go ahead and do this and set it up so there actually is a kernel ready for you to load. And that's Mamba install IPython kernel. Okay. And this goes ahead and generates all the specific dependencies needed to add that kernel to your environment, right, or to your Jupyter Hub, so you can load it up just by clicking it, and you can have that specific Python version. So I'm going to do something dangerous and try it out right now. Let's go ahead and see what happens. IPy kernel. All right. Oh, wait, I'm on Python, sorry. Make sure you are not on Python, and make sure you're also in your environment before you do this. Where is this command? Oh, wait, no, I need to just copy it and run it correctly. Did I spell kernel right? Dang. You can see it goes ahead and we'll go ahead and like start looking for the dependencies needed to build this thing, right? And once it goes ahead and finds all those little dependencies, it's going to do the exact same thing. Say, oh, I need to download 7 megabytes of data to install this whole thing, right? I'll go say, sure, 7 megabytes is tiny, right? And I'll go ahead and set up all that for me, right? And from there, we can go ahead and hopefully have this ready to go on our Jupyter. I'll go ahead and like let this spin for a second because it needs to download a bunch of little stuff. But yeah, let's go ahead and finish up these slides, and I'll go back to this at the very end. Okay, quickly, sharing environment between people. Super simple. Essentially, there's commands here that allow you to go ahead and just like, you know, you can load someone's Conda environment directly from their directory, right? Just by doing like module load or Conda activate, right? And then whatever the path is to their environment, you just pass that path to them, right? And they can go ahead and just run that willy-nilly, right? Do whatever they want, and they don't have write access to it, but they do have read access to it, so they can go ahead and start like running whatever applications they want with your environment. Okay. Yeah, again, you need to have read permissions for this, right? So if you're very strict about your permissions and set it so no one can read it, then I would make sure that they're in your group and they have read permissions. But beyond that, yeah, if they have write permissions, then they can add and remove, and that will update, that will affect you too. So make sure that you don't give them write permissions unless you want that there. Okay. Next, IPy kernels. Those are only accessible to the person that owns the environment. That being said, you can go ahead and run conda create kernel, right, using other people's environments. And they can go ahead and build whatever kind of environment they want to have from your environment, right, and have it available on Jupyter. Okay, you can see some examples here. I'm gonna like slowly creep past this. Reproducing environments using YAML files. So cool one, very cool one. If you want to pass your environment around, right, in a really modular kind of sense, you can give a YAML file to people, right, and actually build using that YAML file, right? So what you need to do is you need to create the YAML file first, right, with this command here, conda env export -- from history, right, and then you give whatever name that you want to go ahead and export into a YAML file, right, and then you give the YAML file that you want to export to. And this will go ahead and like list out all the different install requests, right, that you had specifically in your conda environment. Okay. From there, right, you can also go ahead and export a very specific version of your environment as well. But I won't talk too much about that because I didn't talk about versioning in Conda. So apologies on that. I'm kind of low on time, so I don't want to dig too far into that. Lastly, if you want to go ahead and do the build, right, all you need to do is run mamba env create, all right, and then add the -f flag at the end with whatever the YAML file that you provided. Go ahead and do the entire build directly from the YAML file. Okay, super convenient, super portable. So you can also configure some default behaviors with Conda using the conda rc file, right? Specifically, if you have specific channels, which are like essentially basically like big repositories of different modules and different like software or libraries you want to install in Python, right? Like you can go ahead and configure it so your channels include certain things like R or whatnot, right? So this all exists in this file called conda rc, and this is in your home directory. It's also in this like larger directory here, but you'd want to modify your home directory one. Okay, that would override the system stuff. The system stuff is this default right here, right? It already adds all these little features for you. Notable changes in our conda module. We use Conda Forge. So that's not the base Conda channel. That's actually like the kind of open source, big, widely developed Conda kind of channel. Yeah, and we also limit Conda using 2 threads to avoid heavy load on login nodes. Okay. Oh, and lastly, we create these environments in work. It's a very specific directory in work, so you don't need to worry about like specifying a very specific directory, right? It just goes ahead and throws it in work. Okay. Cool. And you can also track and revert changes in environments. So that's like, you can go down the rabbit hole of Conda, right? But you can list all the different revisions and like look at your Conda history too, right? So yeah, all this stuff is available for you to go ahead and like revert and undo features, right, that you might want to have as well. The 2 commands here, conda list revision and mamba install revision, right? And you can get whatever revision that you want to have. Okay. Lastly, we'll talk about the sysl environments, right? So we have a bunch available for you, including R, right? So if you're a big R user, you can go ahead and use R on Conda. But yeah, basically NPL is the NCAR Python library, right? So you can load that in. There's a default version, which is the most updated one. And then there's smaller versions, right? If you want to stay on an older version, then go ahead and like select the older version, right? And you can go ahead and pull those out, right? Whenever you want. They're updated 2 times a year. So yeah, expect a new one here, I think soonish. I'm not super sure if it's like soon, but yeah. 6 months, yeah, soon. And yeah, you can also see all the different packages inside an environment by doing conda list -n and then whatever environment that you want to have. Okay, you'll see everything listed there. And lastly, some general recommendations. Avoid using pip unless it's absolutely necessary. If you need to, then include pip at the very end. I would not really recommend doing it because you can break a lot of stuff. So yeah, be careful about it. Make sure that you're not digging too far down into using pip and conda. I would probably just stick with conda until you absolutely need to use pip. Okay. You don't want to mix too many different channels here. I'd recommend using Conda Forge because it's a lot more updated and it's community driven. And use Mamba instead of Conda for complex installations. It's just faster. Okay. Cool. Lastly, so quick thing I want to have everyone do before we take off here, right? If you can log into Jupyter Hub with your credentials, right, at the same time, we'd really appreciate it. We currently have an issue regarding a login system. I wanted to do an interactive tutorial in this demo, but unfortunately, we just have some login issues. So we want to make sure everyone just try to log in as like right now, see how it goes, right? And if it breaks, then.
And I would add, even those of you who might currently be logged in, willing to log out and log back in, we would certainly appreciate it. The crux of the issue here, and those of you who've been experienced with our Jupyter Hub for the past 6 months or so, this has really popped up. When we have a flood of logins, the backend server has timeout issues that up until hopefully last week, we installed tooling to better identify it. So we are intentionally trying to trigger a previously known failure mode with our admins monitoring the systems at the same time. So the last thing that stands between you and lunch, yeah, if you're willing to, please go to jupyterhub.hpc.ucar.edu and log in. I'm going to log out of my own session and try the same thing.
Yeah, same thing. But yeah, beyond that though, I'll go ahead and close out for everyone else that just wants to get lunch. Make sure you go to our documentation site, right? Click help if you need anything, right? Click docs if you want to check out the doc and check out the docs. And thank you so much for everyone attending. I really appreciate everyone sitting through this.